Hello students, this is the second part of section 5.6, solving polynomial equations by factoring. Our objective for this video lecture is to solve higher degree polynomial equations by factoring. And this video should be rather quick, so let's get started. Here we have us solving a polynomial equation with three factors. As is usually the case, the first thing that we want to look for is whether or not this equation has a greatest common factor. And in this case, each of the three terms shares an x. So the first thing I want to do is factor the x out of the equation. So we have x squared minus 19x plus 84 times x gives us 0. Now we want to factor the polynomial, so we're looking at factors of 84. The positive sign tells me they're both the same. The negative sign tells me they must both be negative. The first thing that I notice is 4 comes out of this. And it's going to be 4 times 21. If I make both of those negative, we're going to be at negative 25, which puts us pretty close to the negative 19. So let's try negative 6. Negative 6 gives us a result of negative 14, the sum of which is negative 20. So we're off by just 1 in this case. So let's skip to negative 12. Negative 12 times negative 7 would give me positive 84, and this is the set that gives me negative 19. Since there is no coefficient, I can skip straight to the answer here. I have x times x minus 12 times x minus 7, and that equals 0. The zero product property tells me either this is 0, which means x is 0, or this part is 0, which means x would have to be positive 12, or this part is 0, which tells me x must be 7. So you can see here there are three factors, and so we end up with 3 answers. So let's take a look at an example with 4 factors. The first thing again we see is every single one of these terms has an x in it. So by factoring out the x, we get x to the third minus 3x squared minus x plus 3. And that equals 0. Remember back to what we said about factoring things that have 4 terms. Typically that's done by grouping. So here I'm going to pull out a negative, and that's the only thing I can pull out. So I'm going to make this negative x minus 3. So I write the x minus 3 up here. And if I have x squared, it's going to give me the result I'm looking for. So let's put a 1 here just for good measure. So I have x times, this is really that guy. And that's going to equal 0. So this gives me x times x minus 3 times x squared minus 1, and that equals 0. Well, now hopefully you can see x squared minus 1 is a difference of squares. So we have x times x minus 3, and if we factor x squared minus 1, we get x plus 1 and x minus 1. So this equals 0. So what are the potential 4 values of x that make this equation 0? Well, x is equal to 0, or x is equal to positive 3, or x could be 1, or x could be negative 1. These are the 4 values that make this equation 0. So you can see this is a much deeper world than you originally imagined. You could have polynomial equations with 4, 5, 6. You could have polynomial equations with 10 factors. There are a lot of possibilities out there. And in the next video, we'll take a look at some of the application problems that can be associated with quadratic equations.